Factoring expressions is not as difficult as it looks, especially if you use the ladder method. The ladder method is a technique used in algebra to simplify expressions that involve two terms known as binomials. It is a visual method that involves drawing a ladder and using it to find the factors of the binomial. In this video, I will show you 4 examples, 2 with addition and 2 with subtraction, giving you the confidence you need to be successful factoring expressions. I'll begin with this expression or binomial of 3x plus 42. Factoring an expression means to rewrite the expression by undoing the distributive property. I know that sounds a bit confusing, but let me walk you through it by explaining each step. I think the ladder method is the easiest way to factor binomial expressions. If you have watched my other videos on using the ladder method to find the GCF and the LCM for a set of numbers, then this method will look very familiar to you. So I'll start by placing the expression in a ladder like this. Then I will look at the 3x and the 42 and determine whether or not they share any common factors. Well, I know that 3 divides evenly into 42, so the number 3 is a shared factor of both of these numbers or terms. So I will place this shared factor of 3 on the outside of the ladder like this. The next step is to divide each term in the expression by this common factor of 3. So 3 divides into 3x one time, leaving just the x, so I will bring it down. I will also bring down the addition sign. And then I will divide 3 into 42 to get 14, and I'll bring that down as well. I will continue this process until I reach a point where the terms do not share any common factors other than 1. And looking at x and 14, I see that I have reached this point. So I'm done factoring, and now I just need to take the information from the ladder and rewrite the expression. I will bring down the shared factor of 3, and I will place parentheses around the x plus 14 and bring that down as well. And that's it. I'm done. Now I want to show you why factoring an expression is undoing the distributive property. Let's look at the factored expression of 3 times the quantity of x plus 14. Now I'll use the distributive property to simplify the expression by distributing the 3 or multiplying the 3 to each term inside the parentheses. 3 times x is 3x. I'll bring down the addition sign, and 3 times 14 is 42. The result is the original expression that I started with, 3x plus 42. Let's try another expression with addition, and then I'll show you a couple more with subtraction and an extra variable. The first step is to place the expression in the ladder. Then looking at 36 and 9, I see that they share a common factor of 3. Then I'll divide 3 into 36x to get 12x, and 3 divided into 9 is 3. Looking at 12x and 3, I see that they also share a common factor of 3. Dividing 12x by 3, I will get 4x, and 3 divided by 3 is 1. Now, since 4x and 1 do not share any more common factors, I will multiply the 2 shared factors of 3 to get 9, and I'll place parentheses around the 4x plus 1 and bring it down. And that's all there is to it. Now let's take a look at some expressions with 2 variables instead of just 1. Here we have an expression with 2 different variables, 18t minus 36x. You factor these types of expressions using the same process as we did before. So I'll place the expression in a ladder. Looking at 18 and 36, I see that they share a common factor of 2. Next, I'll divide 18 by 2, or 18t by 2, to get 9t, and 36x divided by 2 is 18x. 9 and 18 share a common factor of 3. And after dividing, I have 3t minus 6x. And 3t and 6x share another common factor of 3. Again, after dividing each term by 3, I am left with t minus 2x. And now these 2 terms do not share any common factors, so I'm done factoring. The last step is to multiply the shared factors on the outside of the ladder to get 18, place parentheses around the t minus 2x, and I'm done. In this next expression, each term has the variable y with it. But in the first term, the y is squared or has an exponent of 2, which is different than the y in the second term. So let's see how I factor this type of expression. I see that both 24 and 88 share a common factor of 2. After dividing each term by 2, I have 12y squared minus 44y. And 12 and 44 share a common factor of 4. Dividing 4 into each term now leaves 3y squared minus 11y. Now, if you look at just the coefficients of 3 and 11, you might think that I am done factoring, but I'm not, because each of these two terms share a common variable of y, which I also need to factor out. Following the rules for division with exponents, 3y squared divided by y leaves 3y, and 11y divided by y is 11. Now I'm done factoring. So I will multiply the shared factors on the outside of the ladder to get 8y, place parentheses around the 3y minus 11, and I'm done. I hope that you're feeling a sense of mission accomplished, because the more confident you feel in math, the more successful you will be.